Okay, we are starting 8.2 properties of chords in a circle. Chords are very similar to radius, except that it's not going to be through the center of the circle anymore. It's going to be in different parts of the circle. So a line segment that joins any 2 points on a circle is a chord. A diameter of a circle is a chord through the center of the circle. And the chord and its perpendicular bisector and the center of the circle are all related. So we have 3 properties here. The first one is the perpendicular from the center of a circle to a chord bisects the chord. That is, the perpendicular divides the chord into 2 equal parts. So what that says is that this line right here is perpendicular to this chord here. Let me draw that in red just to keep with our lines here. And that creates 2 equal parts. So that means that AC is equal to CB, which is really helpful when we're creating our triangles. And don't forget that this is always 90 degrees because it is perpendicular. Our second property is the perpendicular bisector of a chord in the circle passes through the center of a circle. So this line has to pass through the center of the circle. That just tells us that it will pass through the center. So if we extend the line, we can use it as our diameter as well. Perpendicular to the chord property number 3, a line that joins the center of a circle and the midpoint of a chord is perpendicular to the chord. That helps us create these lines here and our right angle. And those are our 3 properties, so let us jump into some questions where we get to apply those. Determining the measures of an angle in triangles within a circle. So point O is the center of the circle. Line OC bisects, that means cuts in half, chord AB, such that the angle A, or angle OAC, remember that indicates that angle A is 33 degrees. Determine the values of X degree and Y degree. So let me redraw this triangle. Bisect it, cut it in half. Know that these create right angles. These must be equal. Y degrees here, X degrees here, and 33 degrees here. Now, if we remember our triangle properties, we know that this triangle is isosceles. So, an isosceles triangle means that we have a oblique angle here, so an angle that's greater than 90, and that these 2 angles must be the same. X degree here, and this must be the same due to isosceles. So X degree is equal to angle A because triangle AOB is isosceles. I forgot how to spell it. So X degrees is equal to 33 degrees. And then if I'm looking for angle Y in this, let me redraw my triangle. I only care about this part. I know this is 33. This is 90. And I need to find Y degrees. So then Y degrees is equal to 180 degrees minus 90 degrees minus 33 degrees to give me 57 degrees. Easy. Nothing new. Refreshing knowledge, remembering our triangle properties, and our triangle properties here. Bisecting a chord with a radius. So radius CD bisects chord AB. Chord AB measures 8 centimeters. The radius of the circle is 5 centimeters. Let me redraw this. E and D. So the information that we are given here, chord AB measures 8 centimeters. Now that's helpful, but only in the regard that we know that because this is a chord and it's bisected, these 2 should be perfectly equal. So that means this should be 4 centimeters, this should be 4 centimeters. Now it says the radius of the circle is 5 centimeters. Where would that be? It wouldn't make sense for it to be from C to E because that doesn't go all the way to the end of a circle. It also doesn't make sense for it to go from C to D. So I would say that it should be here, your hypotenuse, because it is the shortest distance to the edge of a circle. We can clearly see in this diagram that C to A is shorter than C to D. So this to me just looks like a right angle triangle all of a sudden. So let's resketch. We have 5, 4, A, C, E. And I want to find this length here. That's my x. So then let's plug this in. This is 5 squared minus 4 squared is equal to x square rooted. The square root of 9 is equal to x, so 3 centimeters equals x. So again, nothing quite new. It's just using those old bits of knowledge that we have. It's remembering that when we have a chord and a radius that bisects, we can do it this way. And it says here that the radius bisects the chord AB. So if we look here, and I just want to remind you that it says that this is 5 centimeters, which is helpful, but there's no way for us to figure out just this from that information. So it makes more sense to have the 5 centimeters here, because we know that we can draw this out anyway from point of the origin to find the radius. So that's my correction there of why we put it at AC rather than CD, is because it's way more helpful for it to be here than it is for it to be in this CD spot. Okay? Next question. Using the Pythagorean theorem in a circle. So as we can see this mess of lines that's happening in this circle, we don't have a triangle. We know that we have AB that is a diameter with length 26 centimeters, which means that our radius should be 13 centimeters. CD is a chord that is 10 centimeters from the center of the circle. What is the length of this chord? So that if this is a chord and this is center O, this should bisect it, making those two equal. Then we can also create a right triangle just like that. So what that means, let me redraw it for you. So we have O, D, and that was little letter E there. That means this is 13 centimeters. Because like I discussed in the last question, it doesn't matter where this line goes. These are all 13 centimeters. I'm going to color code that so you guys can see. So that's 13 centimeters. This is 10 centimeters, and we're looking for this guy. So that'll be 13 squared minus 10 squared square rooted is equal to O, which gives us 8.3, but that doesn't answer the whole question because I need to find the full length. So then CD is equal to 2O. That's a terrible. Let's change that to ED. So then CD is equal to 8.3 times 2, which gives us 16.6 centimeters. And then I have some key ideas down here for you guys to remember. And these are just kind of a quick little summary. The perpendicular of a bisector passes through the center. The perpendicular bisector of two distinct chords intersect at the center, so on and such. If you have any questions, please let me know.